Hi everyone. As we discussed in the introduction video about retrieval augmented generation and its components, let's now talk about one of the core concepts that make RAG so powerful: embeddings. AI doesn't understand plain text the way humans do. It converts text into numerical representation called embeddings. Let me tell you why embeddings are important. If I say it's raining cats and dogs, you immediately know I am not talking about pets falling from the sky. You get the meaning because your brain uses context, experience, and tone to make sense of language. But here is a catch: AI doesn't work like that. For AI, plain text is just plain text, a string of characters. It doesn't understand text in the way humans do. So, how can we help AI capture the meaning behind the words? This is exactly where embeddings comes in. Think of embeddings as a language of numbers for AI. When you input a word, a sentence, or even an entire paragraph, an embedding model transforms that into a vector, a list of numbers. These numbers aren't random. They represent the meaning and context of the text in the mathematical format that AI can process. For example, if I use two different sentences, how do I reset my password and step to recover login credentials? They don't use the same word, but the meaning almost the same thing. And when you convert both to embeddings, their vector will be very close together in what's called vector space. This allows AI system to recognize the text if the exact wording is different. This is why we say AI can search by meaning, not just by exact word. It is what makes RAG so powerful. Instead of returning only documents that contain the exact same word, it can fetch content that relevant in the context. One more thing, not all embeddings are created equally. The quality of your embedding model really matters. A high quality model like OpenAI Text Embedding 3, BART, or Sentence Transformer does a great job of capturing both semantic meaning and context, which is essential when building a system that rely on understanding like chatbots, search tools, or RAG-based application. Let me explain the embedding through this image. As you can see, the data object is our input file. It can be a text file, a video, or an audio file. We pass those input data to our embedding model. Then our embedding model will convert it into vectors, a 2D array of numbers. To sum up embedding, we can say embeddings are what allow AI to understand what you are saying, not just how you are saying it. And that's a huge leap from traditional keyword matching. Now, in the next slide, we will see how exactly embeddings are generated. Let me explain you step-by-step process of how embeddings are actually generated. First, we start with the input text. This can be a sentence, a paragraph, a document, or it can be an audio file or a video file. For example, let's say artificial intelligence is transforming the word is the content. Next, this text is passed through a pre-trained embedding model. These are advanced embedding models like OpenAI Text Embedding 3, Google's BART, or Sentence Transformer. These models have been trained on vast amount of data to understand language pattern and context. The model then output a vector. This is high dimensional array of numbers, something like, as you can see, an array of numbers. This vector captures the essence and meaning of the original sentence in numerical form. Finally, we store this vector in a vector DB like Pinecone or ChromaDB. This makes it easy to later search, compare, or retrieve similar text, not by exact word, but by meaning. In short, embedding are natural fingerprint of language generated by AI to capture both the context and the meaning behind the text. The second image is the visual representation of how embeddings are actually stored in vector DB. We will be explaining this in next video when we will learn about vector DB.